Hello, let's begin our class. Uh, I updated the quiz results and you can take a look. And I also updated the accuracy of assignment 3. And the deadline is today, midnight. So I think most students get 100 accuracy. And if your accuracy is not 100%, this means there is still an issue with your program. So you need to test all the input-output samples. And I also updated the accuracy of assignment 4. And many students get -2. And -2 means your program output does not follow the requirements of assignment 4. You need to read the assignment instruction carefully. For example, so here the instruction is you cannot modify the two functions, read student grades and display semester grades. I saw some students output additional line breaks inside the two functions. And if you do this, the evaluation program cannot extract the required field from your program output properly. So you cannot modify any input-output statements. From this example, some students think the program should output a line break here because we see a line break here. But actually, the line break is input by the user. So here the line break is not a program output. And if you take a look at the code template, you can understand the input behavior required by this assignment. So here the input function is read student grades, and you can see its definition. Its definition is here. So after print this message, then the user will input number of students, and then you need to output the second message. And you notice that here the program does not output a line break. So if you compare this example, you will understand the line break is entered by the user. So here the line break is not the program output. And if you output additional line break here, then the evaluation program cannot extract proper fields from your program output. So the instruction is that you cannot modify this function. And similarly, when displaying the outputs, some students output additional line breaks inside this display semester grades function. If you output additional line breaks, this will also cause the evaluation program not able to judge your program properly. And if your score is not 100, and this means some issues there is still some issue with your program. So you need to test all the input-output samples. And And this time I added two additional samples at the end of this file. So, for example, we have tasks, two tasks. If the second task, if your accuracy is 94 or 97, you can test the additional two samples. So, for example, if your accuracy is 94 or 97, this means your program still have a problem, but it is very minor, and you can use the two additional samples to test your program. So next week I will release assignment 5, our last assignment. And in the previous week we learned vectors. Vectors is a dynamic array. You can delete or add elements to a vector. And this week we will learn strings. Strings is also similar to a vector. You can for C++ string, it is like a vector. You can dynamically adjust the length of a C++ string. And let's see the slides. So first we will learn C strings, and the second part is about C++ string. The third part is about string input output. Besides C in and C out, we will learn additional functions like getLine to read user inputs. So first, C string is introduced in the C programming language, and it is a static array, and each element is a character. And C string has one additional requirement. This requirement is the last character is the null character. So the null character is the \0. And actually, each character can be treated as a integer. So you can print its integer value. So you can use typecasting to print the integer value of each character. For example, for the letter A, lowercase, its integer value is 97, and for letter C, its integer value is 99. And here we also have a null character. The integer value of the null character is 0. And you also notice that the size of this string is 5. But on the right hand side, the size of this array is 5. But on the right hand side, you only specify 4 characters, ABC and null character. So on the right hand side, you only have four characters, and you have one character unspecified. And according to the C++ rule, the unspecified character will be set to 0. So here you see the unspecified character is set to 0. So you can see from this example, you declare a character array. Its size is 5. And on the right hand side, you only specify 3 characters, H, I, and the null character. And the 2 remaining characters are not specified. And the remaining characters are set to 0s. And here, because the integer value of the null character is 0, so here you see I write a null character. So here you can repeat these experiments. So here I declare a static array, a character array, and actually it's a C string because here I use a double quote. And this means this C string will have 4 characters. The first character is A, and here I print the integer, the corresponding integer value. In fact, you can print its you can print its original. You can print the character first. So here I add parentheses to enclose the character. So you see that this string, this character array has four elements. The first element is A, and the last element is enclosed by the parentheses. You cannot see it because it is the null character. It is different from the space. So here inside the parentheses is empty, not a space. So actually this is the null character. And you can print its integer value. Its integer value is 0. So here I perform typecasting. And then if you can modify this example. For example, I specify its size to be 5. Oh, sorry. So here. So for this example, if you use the size of operator, size of will return the number of bytes in this variable, and this variable is a character array. So its size, you will have 4 bytes for CSTR, because each character has 1 byte, and we have 4 characters. So this CSTR has 4 bytes. So size of will return 4. And you can modify its size. If you set the size to 5, then size of operator will return 5. And this time, we have one additional element. This element is not specified because the right hand side only has 4 characters. So we have one element not specified, and this element will be set to 0. So you see here, one additional element is set to 0. If you specify more elements, the remaining elements will be set to 0s. Or you can you can use this version to print each character. You see the null character at the end of this array. The next slide is about the assignment and the equality operator with C strings. For C strings, you cannot use the assignment operator. This is illegal because the C string does not support this assignment operator, and also C string does not support the equality operator. So you cannot use the equality operator to compare two C strings. This will not cause syntax error, but this will not give you the desired result. And we can do some experiments about this. Suppose I want to assign a C string hello to CSTR, and this will cause syntax error. Because for this assignment, because C string does not support this, even if you modify its size, if you change it to 6. So we see this invalid array assignment because C string does not support this operator. And to do string copy, you need to use a function, strcpy, and this function is defined in the C string library. So here you need to use the string copy function. This function is defined in the C-string library. And you need to pay attention to the array size, because if this size is smaller than the string you want to copy, and you see because the capacity is not sufficient, the capacity is only 3 characters, but the string you want to copy contains 6 characters, so string copy fails. So you need to ensure its size is large enough. So to use C-string is not convenient, because you need to consider about its size, whether the memory is large enough to contain the string you want to copy. And you can compare this with C++ string. C++ string is more convenient and more intuitive to use. So from this example, here I include the string library. This is for C++ string, while the C string is for the C string. And here I declare a C++ string. So you don't need to use brackets. And here you can directly use the assignment operator to assign some C string to a C++ string. So the syntax is legal. And it is very convenient. So you don't need to care about the size. You don't need to care about the array size. So you can directly perform string assignment with the assignment operator. And you see here, you see CPPSTR. And actually, you can also print its size. And you notice that you declare this C++ string without initialization. So its initial size is 0 because you do not initialize this string. So initially its size is 0. And then after you perform the assignment, its size changes to 5. This size does not include the null character. So the size refers to HELL, so the null character is not included. So you see actually the C++ string is a dynamic array. You can dynamically adjust its length. Initially its length is 0. And after you perform some assignment, the length is adjusted to 5. So actually, string is like a vector, and a vector is a dynamic array. And next, you can try to use the equality operator to compare two C strings. And you will see the syntax is legal. You can do this. But this will not give you the desired result, because if here it returns 0. For this expression, returns 0. And if you modify, compare with another C string, you see it always returns 0, no matter whether the two strings are the same or not. So this will not give you the desired result. And you need to use another function defined in, you need to use the strcmp string compare. And the next, we will have a quiz. So please raise your hand if you need the answer paper. So this is about vector. You need to compute the value of sum after these statements. I know some of you rely on the mobile phone to compute the answer. I know this. But if you do this in the final exam, you don't have a mobile phone. So this will not help you in the final exam. Uh, 30 seconds left. Then I will turn on the second question. The second question is also about vector, and you need to determine the values in list after the three statements. Uh, 30 seconds left. Then I will turn on the third question. This question is about the resize and resize resize function. And after the four statements, you need to calculate the value of score data size and the score data capacity. And this question has assumption. It assumes the vector's capacity doubles whenever it needs to be increased. And I will turn off all the questions. If you use answer paper, please submit your paper to me. Let's see the answers of the quiz. So for the first question, the answer is 24. And here we initialize this vector by this array, and we specify we start from the index 1. So here is index 1. Index 1 is 3. And you will copy 4 elements because 5 minus 1 is 4. So we start from index 1 and we will copy 4 elements. So the vector contains the 4 elements. And if you sum the 4 elements, you will obtain 24. For the second question, the answer is option 4. And here you initialize an array. This array contains 3 elements. Then you perform insert, and we specify the location is at begin plus 2. So if you specify begin is at index 1, at index 0. So if you specify begin, then you will insert before 5, and the plus 2 will be insert before 7. So after this insert, you obtain 5, 6, 1, 7. And we have the second insert, and this insert specify the same location. So now we have 1, 6, 5, 6, 1, and you will insert 2, negative 1 before 1. So you will insert 2, negative 1 at the index of 2. So the final vector is option 4. For this question, the answer is option 3. So here we use resize. So after resize, the capacity is set to 100, and its size is also set to 100, because resize will create elements. So after resize, both size and the capacity will be set to 100. And then we have a for loop, and this will increase 50 elements because we use pushback. And the pushback will add 1 element to the vector. And so this for loop will add 50 elements to this vector. So the size is increased to 150. And also the capacity need to be adjusted, because capacity is always larger than size. And here we have assumption. This assumption is the vector's capacity doubles. So here when you're so here, for example, when when you perform first pushback, the size becomes 101, and the capacity will doubles from 100 to 200 because capacity needs to be larger than size. So when you push back one element, and when the size becomes 101, the capacity will doubles to 200. So for this question, the answer is option 3. Actually, you can perform a experiment by yourself. So here you see that after resize 100, both size and capacity are set to 100, and after you add one element to this vector, its size is increased by 1. However, its capacity doubles from 100 to 200. If no questions about a quiz, then we will return to our slides. We talk about equality operator. You cannot use this operator for C-string. You need to use strcmp. And if str1 equals str2, then strcmp will return 0. And CMP returns a negative value if str1 is less than str2. This comparison is by a dictionary order. If we want to compare two strings, and it is determined by dictionary order. Later we will learn about this. And CMP will return a positive value if str1 is greater than str2. So here we see strcmp returns 0 because the two C strings are equivalent, are the same. And if you modify this one, for example, you change it to ABD, then ABD is larger because by dictionary order, D is larger than C. So for this one, we have a negative value because str1 is less than str2. So you see a negative value here. And if you modify to ABB, because B is smaller than C, so here it will return a positive value. And again, just so and again you need to use the function, and this is not very intuitive for C++ string, you can use the equality operator to compare to C++ string. So here we compare CPP str with the C string, and they are the same. So this equality operator returns 1. And if you modify the C string, and this time the two are different. So the equality operator generates 0. So you see, for C string, it is more intuitive to use because it directly supports the assignment operator and the equality operator. Time is up, so let's take a break for 10 minutes. Hello, let's continue our class. We already learned about string copy and string compare. And next, I will introduce string cat. This is to concatenate two C strings. And for this example, let's introduce string length first. This is very simple. This will return the length of a C string. And when calculating the length, the null character is not included. So for this example, we have 6 characters. So when you call the strlen function, you will return 6. So here I modify the declaration. So here the C string, the size is 4 because we need to include the null character. So here size of operator returns 4 because we need to include the null character. And for the string length function, it returns 3. And because the null character is not included. Later we will learn how to implement the string length function by ourselves. This can allow us to understand the mechanism of a C string. And the next function is string cat. This is to concatenate two C strings. For this example, you want to concate the string Lorraine and to concate with another C string in span. And you need to call this function. So here I call the string cat. I call a string cat function to concatenate the two C string, and the result will be saved in the first input. So the result will save in CSTR. And now we have a problem. We have a problem here. You need to ensure the destination here. The first input is the destination. You need to ensure the destination is large enough to contain the concatenation results. So here you need to ensure the destination string is large enough to contain the concatenated string. So here its size is 20 bytes, and the string length is 5. And if you concatenate the two string, and this C string becomes hello world. However, if you do not provide sufficient size, if the size is not enough, you will have a runtime error. So here you can compile the code, but when you run the code, this function code will call memory copy, and memory copy will encounter the overflow because the destination object does not have sufficient memory to contain the results. So from this example, you see C string is very inconvenient because you need to consider about the memory allocation. However, for C++ string, you don't need to worry about this. So I will show how you can do this in C++ string. So here I provide a C++ version. So you see that you don't need to worry about its size. This size will be automatically adjusted. So initially its size is 5. When you use the member function size, this also does not include the null character. Actually, C++ string does not have to deal with the null character. When you perform this assignment, you assign a C string to a C++ string, and in this conversion, in the internal C++ string, in its internal representation, actually it does not use the null character. And if you print the string size, this size is the number of characters in the string, and the null character is not included. And you see, string concatenation is very intuitive and straightforward. You simply use plus, so you can use plus to concatenate a C++ string with a C string. So this is very convenient. You don't need to use the string concatenate. And also the size is automatically adjusted. Originally the size is 5. And you see after this concatenation, its size is adjusted to 11. So for C++ string, it will automatically adjust its size. But if you use C string, its size is fixed. So in the beginning, you need to locate the maximal memory you will use. So you see that if you want to use string cat, you need to ensure the capacity of the destination string is sufficient large. Next, let's see the implementation of the string length function. This will return the length of a C string, and actually it's very simple. So the input is a C string, a static character array, and here we add const because we don't need to modify this array inside this function. So we add the const modifier to protect this input array being modified inside the implementation. And actually this is very simple. We declare index from 0, and then you check each element. Each element is a character, and if this character is not the null character, then you increase the index until the element becomes the null character. And if the element is the null character, then you finish the while loop, and then you can return the index at the position of the null character. And this index will be the length of this C string. And the advantage of this mechanism is you don't need to send array size. For example, if you want to send C string to another function, you don't need to send array size, because you can obtain the array size by string length. So this is the advantage to use C string. But this design also has disadvantage, because if you want to obtain the length, you need to run a while loop. This is time consuming, especially you have a lot of if you have a lot of C strings, and to use the while loop to obtain the string length is inefficient. So this is also this also has some disadvantage. Next, I will introduce the CC type library. This is from the C programming language. In C programming language, we have the C type.h library, and in C++, we will remove .h and add a prefix C. So here I will introduce the CC type library. And this library offers many functions about characters. For example, you can convert a character from from lowercase to uppercase, and you can text whether a character is uppercase or a character is alphabet or not, or you can check whether a character is a digit or not, or you can check whether a character is a letter or a digit. You can check whether it is a space, tab, or new line, or punctuation, or printable. So this library offers many functions about characters. And you don't need to memorize the usage of each function, because if such a function is used in the exam, I will provide the usage. I will provide the usage for this function. So you don't need to memorize these functions. And the next, I will show how to use these functions. You can try to copy the code. So here I use the C++ string. You can also use the C string. It's the same. So here I use a C++ string, and then I will call. Then I will deal with each character in this C++ string. So here I will access each character in this string, and each character will be sent to the isUpper function, and I will print the return value of the isUpper function. So you can see if the input is in uppercase, then you will return a non-zero value. Otherwise, return 0. And we can see the outputs. So we see only the first character returns a non-zero value, because the first character is in uppercase. So only the first character returns a non-zero value, and the remaining characters, if you send the letter E in lowercase, then isUpper will return 0. If you send L, this is also a lowercase, so isUpper returns 0. So this is the first isUpper. Oh, you can change it to other functions. For example, you can change it to isLower. So I changed the function to is lower, and you can see the manual. I think is lower is similar to is upper. So is lower will return a non-zero value when the input character is in lowercase, otherwise return 0. So we see the first character is uppercase, so returns 0, and the second character is in lowercase, so here is lower, returns 512. It's non-zero, and actually this is implementation dependent. So the actual number depends on the library you use. And we see comma. Comma is also not lowercase, so for comma is lower, returns 0. And the space is also a character. So if you send a space to is lower also returns 0. And this is the second line of this function. This is the second line in this slide for the is lower function. And you see the program output is a bit different because here outputs 512, not 2. So the non-zero number is implementation dependent. So next we can test the is punctuation function. The is punctuation function will return a non-zero value if the input is a punctuation. For example, the comma. If you input comma, then the is punctuation will return a non-zero. Otherwise, is punctuation returns 0. So for this input, for this C string, C++ string, the only punctuation is the comma. So only comma will return a non-zero value. And if you want to, if you replace by is space function, the space function will return a non-zero value if the input is a space. So here for this C++ string, we only have one space. And only this space returns a non-zero value. So here you can run the program by yourself. So we see that the space is at index is at index 6. So at index 6, the corresponding output is non-zero. And also you know the so if you change it to its punctuation, for this string we have two punctuation, the comma and the exclamation mark. So you see here 4, and the last output is also non-zero. And here I write a function. To test all the functions in CC type. And here I use the function pointer it's a bit advanced. You can skip it. You can skip this. Next, I will introduce how to implement the is_lower function. So this function will return a non-zero value if the input is a character in lowercase. And otherwise, if the input is not a letter in lowercase, it will return 0. And here is the implementation. It is very easy, only 4 lines. So the input is a character. Here we designed the prototype is the input is an integer, and actually it's the same because a character it can be treated as an integer, and the return data type is also integer because the return data type is either positive or either 0. So the return data type is an integer. And we need to determine whether the input is a letter in lowercase. And you can compare the letter A in lowercase. So you can use the greater than or equal operator, because we can directly compare two characters. So here you recall that so each character corresponding to an integer. So letter A corresponding to 97. So you can directly compare two characters, just like you compare integers. So here we can directly compare CH with letter A. And we need to satisfy another comparison. CH is less than or equal to letter Z. Because only in this within this interval, CH is in lowercase. So if CH satisfy the two expressions, then the function will return a positive value, and the positive value is implementation dependent. You can specify another positive value, and otherwise the function will return 0. So you see the implementation is very simple. You can also have another way to check the lowercase. You can also directly write the integer number. For example, you can directly compare CH to 97. So you can directly compare to the integers. So here we have two choices. You can use the first one. You can use character A, or you can use integer, its corresponding integer values. So which one will you use? You will use the first version or the second version. If you prefer the first version, please raise your hand if you prefer the first version. Oh, okay, very good. And if you prefer the second version, please raise your hand. Okay. I think most of you will prefer the first version because it is most readable. Because this is readable, you understand letter A and letter Z. But if you choose to use integer, you don't understand what is 97, what is 12012. You need to look up the ASCII table to find 97 is letter A, and you want to find you need to find 122 corresponds to letter Z. So the second one is less readable. And actually, you don't need to memorize the ASCII value for each character. You can directly use character for comparison. Next, I will introduce how to implement is-alpha. Is-alpha is to test whether is to test whether the input character is alphabet. So here, first we call the is-lower function to determine whether the input is a character in lowercase. So if the input ch is not a letter in lowercase, then flag will be 0. So if the input ch is a character in lowercase, then it will return a non-zero value. Then if flag is a non-zero value, then we will go to the if part, and the if part will directly return flag. However, if flag is 0, then we need to proceed to the else part. So if flag is 0, we need to call the is-upper function to determine whether the input is a letter in uppercase. And this time, we directly return the flag. We return the output of the is-upper function. So you see the implementation of is-alpha reuse the two functions, reuse the is-lower function and the is-upper function. And this kind of implementation is very common. We usually reuse the existing function. So here we don't need to implement the is-lower and the is-upper again. We also have the to lower function, and to lower is to convert from lowercase convert to lowercase. So if your input is in uppercase, it will be converted to lowercase, and otherwise the conversion performs nothing if the input is not a letter in uppercase. So you see, if the input is a space, then to lower will do nothing because space is not in uppercase. So here you can test the to upper or the to lower function. So to upper is to convert to the input to lowercase. And we can try to implement this function. So for this function, you need to implement the to lower function. So here, after we perform to lower, it shows the integer value. And if you don't want to see the integer value, you need to convert to character. This is because to lower returns integer. So to lower returns integer, so you need to convert from integer to character. So here we see h in uppercase is converted to lowercase. And if the input is not in lowercase, for example, it's a comma, then the to lower do nothing. Or the input is only lowercase, to lower also do nothing. So you see only the to lower function only applies to. So you see the to lower function only modify the uppercase input. And next, we will implement our own to lower function. And to do this, you can understand the mechanism of the C string. So first, you need to determine whether the input is in uppercase, because we only modify uppercase to lowercase. So first, you need to determine whether the input character is in uppercase. And this is very easy. You just compare with uppercase A and uppercase Z. So you can directly compare to the two characters. And then you need to perform the conversion from uppercase to lowercase. And this is a bit tricky. So first you subtract. Uppercase A. And doing this, you can obtain the offset from uppercase A. For example, if CH is uppercase B, then uppercase B minus uppercase A, we obtain 1. So after you perform this subtraction, you obtain the offset from uppercase A. So you obtain an integer. Then you need to convert this integer, this offset to lowercase. And then it is simple. You just perform plus lowercase a. So you can complete the conversion in this in a single line. So for example, you want to convert uppercase b to lowercase b. Then first you need to obtain the offset. So you can perform uppercase B minus uppercase A, and the result is an integer. The result is 1. Then you need to convert 1 to lowercase b. So you perform 1 plus lowercase a, then you obtain lowercase b. And if the input is not in uppercase, then we do nothing. So we directly return the input character. So you see here, I use one example. I subtract the first character. So the first character is uppercase A, and I perform subtraction. I subtract uppercase A, and you will obtain 0. So here you obtain integer 0, and then if you perform plus lowercase a, you obtain 97. And actually 97 is lowercase a. They are equivalent. So below I just perform type casting, and you can test the second character. So we can test the text the second character B. So now C is the second character. So if you perform character B minus character A, then we obtain integer 1. And then you perform addition. So 1 plus lowercase a, you obtain integer 98. And the 98 is actually lowercase b. So they are equivalent. So you see, we can convert from lowercase to uppercase, or you can convert, and you can do vice versa. So again, you see, you don't need to memorize the ASCII value for these characters. You can directly use character to for comparison. So here we have finished the introduction to C string, and next we will proceed to the C++ string, and we already learned some of the usages. You can use the assignment operator to perform assignment. And you can use the at function to access each character in this string. So and because string is like a vector, so you can use member functions in because string is like a vector we just learned, so you can use the at function to access each element. And if the index is out of range, then this function will throw an exception, and you can catch this exception to deal with the runtime error. So here, similar to brackets, so you can use at function to access each element. And if it is outside the legal range, for example, you increase the size. So here, if I is equal if I is equal to 3, then this will cause index out of range. So this will throw an exception. This will cause a runtime error. So you can immediately know here we have a problem here. But if you use brackets, you might not notice such error occurs. So here I use brackets, and you notice that we have a problem here. We have index out of range. When I equals 3, then this will lead to index out of range. However, if you use brackets, you will not notice such error. And only if you use a member function, you can detect such error. The next slide is about string operations like initialization or assignment or concatenation. Because time is up, so let's take a break for 10 minutes. Hello. Let's continue our class. I will introduce how to use C++ string, and you can first let's initialize initialize C++ string. You can use the assignment operator, or you can use parentheses. This is called constructor. Later we will learn. When we define our own classes. We define our own data type. We will learn constructor. Constructor is a function that will be automatically called when you create an object. So the two are similar. You can use assignment to initialize a C++ string, or you can use the constructor. And you can use C string or C++ string for initialization. And after initialization, you can directly use the assignment operator. You can assign C string or C++ string. And for concatenation, we can use the plus equal operator, or you can use the plus operator for concatenation. So here you can concatenate with a C string, or you can concatenate with a C++ string. Here my string is a C++ string. So here, you can use the plus operator to perform string concatenation. So you can concatenate concatenate C++ string with a C string. So CPP str is ABC and C string is hello. So you see the concatenation results. And actually, you can perform a chain of concatenation. For example, you can concatenate with other C string. So you see here we concatenate with C strings. And here you need to know the order of the sequence is important. You cannot perform you cannot concatenate two C strings. For example, suppose you want to perform if you modify the expression like this, you concatenate a C string with word, and then concatenate concatenate with C++ string. Then you will obtain some syntax error. This is because you need to pay attention to the precedence. If you have two operators, you need to determine which operator will be carried out first. So here we have two plus. So the first plus will be carried out first. And however, the plus does not support C strings. So you cannot use plus for two C strings, because for this plus, both inputs are C string. So for this operation, this causes syntax error. So here we cannot use the binary operator plus for two C strings. However, if you modify the sequence, here I modify the sequence. I change to C++. I move C++ to the first concatenation. Then this becomes legal, because the input is a C++ string and a C string. So this is legal. And then you know the result. The result is still a C++ string. So you can concatenate a C++ string with a C string. So when you perform a chain of string concatenation, you need to pay attention to the precedence. And we already talked about the size function. You can use size to get the length of a C++ string. You can also use the length function. They are the same. And you can use the at function to access each character. And we also have more functions, more string functions, like find. You can find some substring in a C++ string. Then you can also use rfind. Rfind means reversity. You find reversity from the end of this C++ string. And you can also use substring. Substring is to obtain a substring from the C++ string. You can specify the position, the starting position. And here I will skip this slide. And this slide is not included in the final exam, in the scope of the final exam. But this is useful when if you want to deal with string operations. Next, let's consider about the conversion between C string and C++ string. We can convert from C string to a C++ string, and this is legal. However, the reverse conversion is not legal, so you cannot assign a C++ string to a C string. This will cause syntax error. And to do this, because sometimes you need to deal with C programming language, so sometimes you need to downgrade to C string. So sometimes you need to convert from C++ string to C string. And to do this, you need to call a member function, C underscore str. And this will return a C string, a static character array. So if you want to convert from C++ string to C string, you can use the C underscore str member function. The next slide is how to reverse a string, and you can run this example by yourself. So I will skip this one. The next slide is about the conversion between string and numbers. Here, numbers means integers or doubles. Because if you want to perform arithmetic operations, we need numbers. Because strings, you cannot use string to perform arithmetic operations. So if we want to perform addition, then you need to convert string to integers or doubles. So here, if you want to convert from string to integers, you can call the function stoi, and this function is defined in the string library, and this will convert the C string 35 to integer 35. Then you can perform addition or subtraction. So here, for example, you want to perform addition plus 3. However, this is not supported because this is a string, not a number. So you need to convert to a number. So here I convert to integer. Then you can perform usual addition. The result is 38. And you can also convert to a double. So if you want to convert to a double, then you use stod. So here, suppose we want to perform so you can convert to a double, or you can perform division. So you see here is a floating point division because stod will return double, and stoi returns integer. So integer will perform integer division. And you can also convert from integers to string. So you can call the member function toString to convert from numbers to strings, to C++ string. Next, I will introduce how to implement stoi, how to implement from to convert from string to integer. So now suppose we have a string 5, 6, 7, 8, 9, and you want to convert it to an integer. You want to obtain its integer value. This is decimal number system. So here we need to understand what does this number mean. This number means first you need to count its powers. So 9 corresponds to power 0. So 8 corresponds to 80. So 80 means 8 times 10. And the 7 means 700. So 7 times 10 raised to 2. And similarly, so 5 means 50,000. So means 5 times 10 raised to 4. So now we understand how to compute the integer value. So you need to convert you need to convert this this process to code. So here is you need to convert this process to C++ code. And to do this, first we declare a variable string length. This length is to understand the maximal power, the maximal value of power. So if the length is 5, so the maximal value of power is 4. Is size -1. So this length string length is to determine the maximal value of power. And the maximal value of power is length -1. And then we need a for loop. The for loop is to process each character. So we can use the for loop to get each character str at index I. Then you need to perform conversion. You need to convert to integer value. So here str at the index I is a character. So you need to subtract digit 0, character 0. If you don't do this, you will have a problem, because you will use the numerical value of the ASCII value of this character, and this is not what we want. We don't want to use the ASCII value of 9. So here you need to perform the subtraction. You need to subtract character 0. And actually you can perform an experiment by yourself. So here I convert to integer value. So and you will see that the first character is 5, and its integer value, its ASCII value is 53, not 5. So when you perform suppose you multiply 10, you will obtain 530. And so we need to convert from character to its integer value. So here you need to subtract character 0. If you perform character 5 minus character 0, then you obtain 5. Then you can perform the ordinary multiplication. So here, if you want to perform 5 times 10, you need to subtract character 0. Otherwise, you don't obtain the desired results. So here for each character, we need to subtract character 0, then we can obtain the numerical value. Then we perform, you need to multiply 10 raised to power. So here, we call the power function, and this will raise 10 to str power. And the str power begins from string length -1. So actually, we begin from this character. We begin from 5, because at the index 0, the character is 5. So we begin from this, and the 5 will multiply 10 raised to 4, and the 4 is str power. The initial value is string length -1. And then after you compute the results, then we save. We add this value to str value. Then we proceed to the next character. So we proceed to character 6. And again, we perform the same computation. We perform minus character 0, and then we perform 10 raised to power, str power. And because str power is decreased by 1 in each iteration, so here 6 will times 10 raised to 3. And then you will continue the process to each character. Then finally you will obtain the final str value. The final str value will be the integer value of the input string. You can try to implement this function by yourself to see whether you understand the mechanism about how to convert from string to integers. And we have finished the second part. Next, we will move to the third part. The third part is about string input-output. For string input-output, we already know we can use cin. You can use cin to read user inputs. And below are some behavior about the cin object. When you use cin, the program does not read the input until you press the return key. So this means you can use backspace to correct mistakes, because before you press the return key, you can still have chance to fix your inputs. And one feature of the cin object is cin will skip any blanks. Blanks means space. Will skip space or line breaks. So you cannot use cin to read space or use cin to read line breaks. The next one is an example about cin. Suppose we declare two C string, and we use cin to read user input, and the user input will be directed to the two C strings, and then I will print the two C strings. Then we can try to run the code. You see here, I type some words, and you still have chance to fix. You can use backspace to correct your inputs. After I type return, you see the first flight is saved in C string A, and then I type a space. This space is ignored, so this space is skipped. Then I type me, and the me will be saved in C string B. So when I output A and B, you will see fly me. You can also input more strings, like so suppose I input 3 strings. You will see only the first two words will be directed to A and B, and the third words will be discarded because we don't have a third variable to store the third word. And sometimes you want to read the whole line. Sometimes you want to read the space. If you want to read the space, then you need to use another function. You need to call cin.getLine. So if you want to read the whole line, you can use cin.getLine. So this is the input output with C string. And you can also deal with input output with C++ string. And this is more convenient because you don't need to determine the string size. In the previous slide, you need to estimate the maximal size of the string. So here I declare the maximal size is 80. However, if the user input is larger than 80, then the following code will have problem. But if you use C++ string, here you don't need to worry about the string size. Because C++ string is a dynamic array, it can automatically adjust the size according to your operations. So you can do the same input-output test. And if you want to read the whole line, you can use getLine. This function is different from the previous one. Previous we use cin.getLine for C string. And the next line you don't need cin dot. You just call getLine for C++ string. The next slide is from the textbook. It's about when you mix the use of cin and the getLine. You might encounter some undesired effect. So here is the example. Suppose you want to read some number from user. Suppose you want to read some integer from a user, and then you want to read a string from the user. And you can write code like this. So first you use cin to read integers, and then you use getLine to read the whole line. And when the user type this input, the result is fine. The result is what we want because number is 42, and the line is fly me. However, if the user input differently, for example, if the user input 42, then the user type a return, and then your program will have a problem. Number is 42, then this is okay, but however the line is empty, so its size is 0. So if the user behavior is like the right hand side, then your program will have a problem. Actually, we can try to test this program. So here I input 42 and fly me, and 42 will saved in number, and the remaining string will be saved in line. And when I press enter, then the getLine will finish it. When getLine is finished, then the program will print the value of number is 42, and the value of line is fly space me. So this C++ string has 7 characters, include the space before fly. So this includes the space before fly. You can add a parenthesis here. So you see the line contains a space, then fly and space and me. So so now the program works as expected. Now if I enter 42 and I press return, then you will see the program finishes immediately. So after I enter 42 and you enter return, then getLine will get nothing. Actually, after you enter return, getLine will be finished. And in this case, line is empty, so its size is 0. And this is not what we want. This is not what we want, because we want to read inputs after the return key. We still want to enter some inputs. And this is due to the behavior of the getLine. So you need to, in order to fix this problem, here is one remedy. You can add a statement cin.ignore. This statement will will discard the line break you input. So your input will be, if you input line break, then line break will be absorbed by this line. So when you write cin.ignore 1000 line break, and this means the program will read and discard the entire rest line up to and including the new line. So this means the contents before the new line will be discarded. So after you add this line, this line can deal with the line break. So and this time you can obtain the correct output. So if you modify the program, the line break will be absorbed by this cin.ignore, and then your following input fly me will be read by getLine. So now getLine, so in this example, line will be fly me, and the length and the size of this string is 6. So you see, now if you add this line can absorb the line break, and then the cin can continue the read the contents after the line break. The next slide is about another 2 functions. You can read one character at a time. If you want to only read one character, you can use get. And get can read white space, while cin is not. If you use cin cannot read white space. So if you want to read a white space, you can use getLine, or you can use get. But get only reads one character, not a string. And if you want to output one character at a time, you can use put. Actually, this is equivalent to cout some character. The next slide is about 2 functions, pick and putback. This is also about character input and output. Here I have one videos. You can see this video. The video is in. We have a reference. We have a reference web page. And actually, this page contains a lot of CPP file. This CPP file contains the code in our slides. You can download the CPP files to practice the examples. And here you can go to the strings, and here is one video. This video introduces pick and the putback function.
Hello, this is Robert, and in this video I would like to demonstrate how cn.get, cn.peek, and cn.putback work. I've set up this little demonstration inside of a graphics program so that I can represent what's going on graphically. So, I set up a stream buffer here, and this is controlled by the operating system. And so when the user types letters on the keyboard, the operating system keeps track of which letters are typed using a stream buffer. And you can see that the characters are filled in from left to right in this example. And so let's say that the user types A first, so that would be stored right there, and then they type a B, and then they type a C on the keyboard, and then let's say they type return. Okay, so when our program starts up, let's say that these are the first few statements in our program. So we set aside memory for ch1, which is a char. There it is right there. Then we set aside memory for another char called ch2, and there it is right there. So when we reach this first cn.get statement, that will remove the first character from the buffer and store it at memory location ch1. So that A goes from the buffer into ch1. And then what happens is the next character to be read moves over to the next byte right there. So when we have the next statement, cn.get ch2, B will be read from the buffer and stored into ch2, and then the pointer for the stream buffer, the next item to be read, will move over to C. If this is the end of our program, then the C will be thrown out. Otherwise, if there was another cn.get statement in our program, then the C would be read. Okay, so it's stored for further input, regardless. And if the program terminates, then it's thrown away. Okay, so let's reset our program so that the user has typed A first, and then B second, and then C. So the first thing to be read will be A. But let's change our program. We're not going to be using just simply get anymore. Let's use a combination of several statements. Okay, so we still set aside ch1 and ch2 right there. But the first statement to be executed is cn.peek. Okay, so peek is very similar to get, except that it will not move the pointer over to read the next item. Remember that that's what we did with get. With peek, we still will read the character from the buffer into ch1, and so we'll grab the A, but this time it's not removed from the stream buffer. So we did make a copy of the A to store it in ch1, but we didn't move over to read the B next. Okay, so with peek, we are still going to read the memory from the buffer. So the A went from the buffer up to ch1, but then the pointer stayed at A. So A was not removed from the buffer, and it will be the next thing to be read. Incidentally, notice that cn.peek uses a different style. With get, we have the character to be read inside of the parentheses right there. With peek, we can't do that. With peek, we have to use an assignment statement and actually store it to the left side of that assignment statement. You're not allowed to put any characters inside of the parentheses with peek. You'll get a syntax error. Okay. Now that we have peeked and we've loaded the first character into ch1, now we will move on to the next statement right here. And so cn.get ch2. Well, the pointer is pointing at A right there, so the A will move into CH2. And then the pointer will move over to read B, right? Because that's how get works.
So here we see both pick and get read one character from the buffer, from the stream buffer. But the difference is that pick does not move the pointer, while get will move the pointer to the next one. So the behavior of pick and the get are similar. They both read one character, but the difference is that pick does not move the pointer to the next one.
Move the pointer over to read the next thing. All right. Put back is sort of the opposite of get. And I've just placed a D in here just because it was something different. I could put back CH1, and then that would place an A back in the buffer because that's what CH1 contains. But you're not limited to the thing that you just read. So I just wanted to make that point. I could put back CH2, which would also put back the A, but you can put back into the stream buffer anything you want. So let's go ahead and put back the letter D. So since put back works the same way as get, only in reverse, the first thing we're going to do is we're going to move the pointer back over to the first location in the stream buffer, or the previous location in the stream buffer. And then what we'll do is we will place a D right there in the stream buffer. So we put back a D. So that's how put back works. It's the opposite of get. Remember that get will remove the character from the stream and then move the pointer over. Well, put back is the opposite. So we move the pointer back over to the previous location, and then we store whatever single character we want in that location. And in this example, I'm just putting back a D. So the next statement after put back is cn.get ch2. All right. Well, we grab the D and we place that into ch2. ch2 contained an A, but since we're placing a D there, the A gets clobbered. And so the D is overwritten, or the A is overwritten with D. And then we move the pointer over, and B will be the next thing read. If there is another get statement or some other statement that reads from the buffer. There isn't, and let's just pretend that the program terminates after this statement, then the B and the C will get thrown away.
So you see from video that the system uses a string buffer to store the user input, and if you want to interact with the string buffer, you can use these functions. You can use pick, get, put back to interact with the stream buffer. And the lesson has come to an end. I think we can now dismiss.